beaches, or the toxins produced by these algae are closing down beaches. They're potentially having harboring, potentially increasing the chances of fish kills and wildlife kills, and also the potential for human sickness. Also, on other systems, are really a big problem. Drinking water reservoirs have a massive problem, oftentimes with these blue-green cyano blooms, and they spend a lot of money to try and deal with them. It takes a lot of money to treat the cyanobacteria toxins when they come through the water treatment. It's not your simple tertiary treatment and chlorination. You need more techniques to deal with that. So they pay a special attention to these. And they can come in a whole bunch of different forms. They can come in these planktonic forms where it kind of tinges the water green. You've probably seen that on Roaring Brook and some of the other lakes around Lake Peekskill. Sometimes they can actually form this kind of surface scum on the top, this pea soup look. And some of them actually, do look like filamentous algae. And there's a couple species of that. Not so much. They don't occur as much in this area as they do, let's say, in the southeast. But that's another way they can look. So some problems associated with cyanobacteria, we kind of talked about this a little bit. Taste and odor producing compounds. Geosmin and MIB are two. It makes the water taste kind of nasty and earthy, and that's something also for drinking water reservoirs they really want to try and get out. And this is a byproduct of just them being in high abundance. One of the things about cyanobacteria is that nobody's really sure why they produce these toxins. There's ideas they think it could possibly be an allelopathic response, which basically means that when the plant is threatened, either through grazing, or maybe a zooplankton is trying to graze it, or there's some environmental condition, it will release it in a defense mechanism. Some say it's a byproduct of just the normal biochemical processes within the algae. The point is that we're not exactly sure, and this is a very well-studied group of organisms, and we're still not sure why they produce toxins. But what we do know is that when they're in high abundance, toxins can follow them. I'm not really telling you guys anything new on that end. Some of the toxin producing, there's a bunch of toxins producing strains. Some of the toxins they produce are microcystin, anatoxins, saxitoxins, some other compounds that are just not so much toxins as far as what we've isolated in the normal toxicology, but some other compounds that have some adverse impacts. I wanted to throw this chart down here, so I pulled this off this morning from the DEC website, and this is basically all the lakes in Putnam County that have had harmful algae blooms, either suspicious, confirmed, or confirmed with high toxins. Not high toxins, but.
Oh, we made it to the list yesterday?
It seems like it, yeah.
We had
That's
spurts.
suspicious, yeah.
We had, it's not a daily, it's usually about a week-long list, but we had 2 beach closures within the last week, and Spur is still closed. Children's has been open.
Yeah, so the way the state classifies these is suspicious is more, you may go to chime in here, Anna. A suspicious bloom is where somebody sees something that looks like a bloom, however it's not tested. Pictures go to the DEC, and the DEC kind of says, well, yeah, this kind of looks like a bloom, but we don't have any testing on it, so we'll put it as suspicious. Confirmed is where you have all the conditions for suspicious, but somebody sends it in for testing, and then the chlorophyll A, which is the most dominant pigment within the algae, if it reaches a certain level, I believe it's 25 micrograms per liter of chlorophyll A. Basically, what it's saying is that do we have the algae, and is it in a high abundance via the analytical technique? And when they say yes, that means the stage goes from suspicious to confirmed. And then the next step they do is that triggers the final step where they actually test for toxins. So they'll test for mostly they'll do microcystin. They won't test for some of these anatoxins and saxitoxins, but they'll test for microcystin, and if microcystin is at a high enough level, I believe it's 4 micrograms per liter of microcystin, then they'll say confirmed with high toxins. You look a little confused. You have a question about that?
It's just I have to keep focusing on what you're saying. So we don't have the high toxins in our lake, then it's just suspicious and it hasn't been tested?
I can't speak for this particular.
So we've done, through the DEC, we've sent 4 samples this year. 1 was suspicious and unconfirmed. 2 were suspicious and confirmed, and 1 was suspicious confirmed and with high toxins.
Okay.
And that's not uncommon,
Yeah.
that a lot of these blooms, even when they're confirmed to be blue-green algae, are not actually producing toxins.
And that goes back to, what I was saying before, is that we just don't understand the conditions under why they're producing toxins. I mean, you have blooms that are completely green and they just won't produce any toxins. We just don't know why. Lake Peekskill, I know in this year at least, has had some confirmed with high toxins, I believe. Some of the other lakes over in Kent and Carmel, Putnam Lake, Lake Carmel itself. Tibet Lake has had a bloom. It wasn't put on here, but that had a bloom as well. And then a bunch of the Westchester ones. Putnam County is actually, when I took a look at it this morning, was the county with the most amount of lakes that had blooms on it. We're not exactly sure why. My guess is that a lot of the lakes in Westchester, even though it's a little more populated, more of them are on sewers. So a lot of the septic system effluent that would normally be going into the lake are going into a sewer system. But then some of the other counties, maybe a little bit further north, Justice, they just don't have the same population densities. That's my guess of why that would be, why Putnam County is had. But also, a lot of the lakes in Putnam County are very shallow. They're very conducive to algae growth. Yep. And leading into our next, so moving on, what fuels algae growth? So why does this algae pop up? Why does it pop up during the summer? Really, it's kind of this trifecta of sufficient light, and if you go back to your freshman year or high school biology classes, photosynthesis, light is needed for that reaction to occur. Temperature influences the growth rate, so how much can they produce, how much they can reproduce and multiply throughout a certain amount of time. And nutrients. Relevant to us in lake management, there's only a certain amount of things we can control. If we're in a pond, if we're managing for a small pond, we can control light, certainly. There's pond dyes we can put in. If anyone ever spent a lot of time in Ohio? For any reason? Well, or even golf courses. So a lot of them have this blue shade to them, and that's actually a dye that some applicators will put in. And the point of that dye is to stop the light from penetrating through down into the water and growing algae. Sometimes it works, sometimes it doesn't, but that's one of the ways. Temperature is really hard to manage for. One of the only ways to do it is through aeration, which you're mixing the water constantly. So stagnant water reaches a higher temperature faster. Aeration can reduce the temperature a little bit, and it's not overly effective at doing that, but that's one way. The point is that light and temperature are really hard to control. But nutrients, while they're hard, we have a lot more strategies to control them. And when I say nutrients, I mean nitrogen and phosphorus, which are pretty much the fuel for algae growth in lakes. Phosphorus is more important in lakes than nitrogen, just because naturally in lakes, phosphorus doesn't occur as much. So the minute there's an addition of phosphorus, the algae gets all excited and says, we have all this nitrogen, but we need the phosphorus. So everything in that water is saying, all right, we need phosphorus, we need phosphorus. So the minute there's an influx, either from the watershed or a lakeshore home or internally, which I'll talk about in a little bit, that algae gets all excited and then it starts to bloom up. And we have techniques to deal with that, depending on not we ourselves, but the lake management discipline has techniques. Depends on what the budget is, depends on what the particular regulations are in a system. And please feel free to stop me anytime, to ask any questions. No questions dumb. So.
Does the phosphorus get bound in the algae? So, for instance, if you remove the algae, would you in fact be removing phosphorus?
In theory, yes. The only thing is that algae, the uptake and the cycling is very fast. So algae will grow, live, especially the planktonic stuff, will grow, live, and die really fast. And then when it dies, all that phosphorus is going to be released back into the system. So with filamentous algae, let's say, you could harvest a bunch of it out. However, one, you're not dealing with the source. That's one of the big themes. You always have to deal with the source of the nutrients versus, just dealing with the symptom of it. And two, there's probably plenty of nutrients left in the water to regrow that algae. On some smaller lakes where we have a bunch of floating leaf plants, like coontail and bladderwort, I know bladderwort has been a plant that's been a pretty big pest here in the last couple of years. That's a plant that takes a lot of its nutrients from the water column. So on smaller lakes where there's a big infestation, removing some of those nutrients could actually maybe move the needle a little more. But in total, probably it won't. Yes, it is bound up to answer your question. But in terms of a management technique, you would really need a really specific And vice versa, you know, they do a lot of, you know, I think you probably know a little bit more about this. You know, in storm and wastewater treatment plants, you can use stuff like duckweed or plants to actually uptake your nutrients and filter out a bunch of these nitrogen and phosphorus. And that's one way to actually help. So basically, does that answer your question?
Yep.